Okay, hashing is a technique where search time is independent of the number of items or elements. In this technique, a hash function is used to generate an address from the key. So there will be one key, and using a hash function, we are going to convert this key into an address. So a hash function takes a key as input and returns the hash value of that key, which is used as an address index in the array. So we can write a hash function like this: h of k equal to a, where h is a hash function, k is the key, and a is the hash value of the key. So using a hash value, we can convert this hash value into an address. So output of this hash function is an address. So we will give an input, a key value, into this hash function, and the output of this hash function is an address, that is index. So hash function. A hash function is any function that can be used to map a data set of an arbitrary size to a data set of fixed size, which falls into the hash table. The values returned by the hash values are called hash values, or otherwise it is known as hash codes, or simply it is known as hashes. So in hash function, actually we are mapping a data set to a particular indices. So these are the requirements. So this is very important question. What are the requirements of a hash function? So what are the conditions for a perfect hash function? So first one is easy to compute. Means it should be easy to compute. Next requirement is it should generate address with minimum collision. Collision means more than one element will be mapped to a particular index. So it should avoid collision. So it must contain minimum collision. And the third requirement is we have to distribute key values evenly in the hash table. So irrespective of how good a hash function is, collisions are bound to occur. Therefore, to maintain the performance of a hash table, it is important to manage collisions through various collision resolution techniques. So first of all, we will apply a hash function to all the numbers. After applying the hash function, each and every keys are mapped to some indices. Suppose if a collision occurs, collision means more than one key will be mapped to a particular index. Then we have to apply some collision resolution techniques. So this is one example. So we are applying a key values. Key value means our actual data. So we are going to apply a hash function on these key value. So based on these hash value, we will get a hash. Based on this hash function, we will get a hash values. So hash value means the indices of this storage. That means the indices. These are the addresses actually. So we will get some addresses of the location. So we will store. Suppose we will get 1, then we will store key value at this position. Suppose the hash value is 5, then we will store the key at this position. For example, consider this example. Consider an example of hash table of size 20. The following, so we are assuming that this is our hash table. So the size of this hash table is 20. This n is 20. And we are assuming that the elements are like this also. Items are in key value format. So first one is key and the next one is value. So here 1 is the key, 20 is the value. So here we are using modulo operator. What do you mean by modulo operator? Tell me what is modulo operator? What is the operation? Hello? What is modulo?
Divide it at a reminder.
Yes, first we will divide it and then we will take the remainder. So here the first key value pair is 120. So 120 means, so first here operation is modulo operation. So we will divide 1 by 20. And what is the remainder? Remainder of this one is 1 divided by 20. What is the remainder? Tell me.
1.
1. So the hash value is 1. Hash value is 1 means index is also 1. So next value is actually next is 270. 270 means we will divide this 2 by 70. And then we will take the remainder. What is the remainder? 2 divided, tell me. 2. 2 divided by, actually there is one mistake. Actually here it is 2 divided by 70. So we will get 2. So array index is 2. So next element like that we have to continue. We have to find out all the values. So suppose, so here, this is actually another example. Here we are having 2 divided by 20. So we will get 2. So this array index is 2. Then next number, key is 42. And 42 divided by 20. 42 divided by 20 means, what is the modulo? 42 divided by 20 and take the remainder. What is the remainder? 42. So we got 2 array index 2 for the key value 2 and for the key value 42 also we got array index as 2. So there is a collision. This means there is a collision. Actually we are going to find a mapping 1-to-1 correspondence between this key value and hash value. Here we got 2 divided by 20 means it is 2. So actually we are taking the modulo operator. 2 modulo 20 means we got 2. Also 42 modulo 20 means also the answer is 2. So we got 2 number. We need to store these 2 numbers 42 and 2 at the location 2. So that means it is a collision. Show 3 columns key, hash and array index. Complete it first. You have to divide this 1 divided by 20 because here we are taking this key value as key is 1 and this hash function is taken as 20. Hello, can you hear me? Hello?
Yes, yes.
Okay, actually we have to divide the key value by hash function and take the remainder. Okay, do it. First you have to write all the keys, then find the hash values. Actually this hash values is same as the array index. Did you complete it? Keys are 1, 2, 42, 4, 12, 14, 17, 13, 37. Okay. So we need a hash function. So this hash function is h of its hash function. So hash function is actually we are selecting the hash function is a modulo operator and the value is 20. Okay. So what is the hash value? First key is 1. So we are taking modulo operator as hash function and this function value is 20. So 1 modulo 20. So we will get 1. Like that you have to complete all the 2 So now we have this table. So we have to create a hash table using this one. So you can draw a table like this. Can you view the slide with the index value?
Yes, yes.
Okay. So draw a table like this with the two columns, index and value. Okay. So what are the indices from this table? Actually, we got 1, 2, 3, 4, 5, 6 up to 17. Maximum value is 17. So throw up to 20 like this. So fill all the values from 1 to 20. So index is ranging from 1 to 20. So then about value. What about the value? What is the value of index 1? Actually, key 1 is stored in index 1. So in the key pair, in the value pair, actually this is another example. In the value pair, you can put 1 here. You can put 1 here. And look at the second value. Here key value 2 is assigned at location 2. So you can place, actually this is another example. You can place 2 here and look at this table. Also key 42 is at location 2. So we can write 42 at this location also. So at location 2, we are having 2 and 42. What about 3? Do you have any value at 3? Tell me. According to this table, no. Okay, what about 4?
4.
Which value?
4.
4. Okay, what about 5? Is there any value at location 5?
No.
6?
No.
7?
No.
8?
No.
9?
No.
10?
No.
11?
No.
12?
12.
Well, key is 12. Okay, what about 13?
13.
Okay, key is 13. What about 14?
14.
15?
No.
16?
No.
17?
17.
Okay, 17,
And
18,
37. 37.
17 and
17 to
30.
37.
Key value is 37. Okay, key value is 37.
17 and 37.
Okay, 17 and 37 is at location 17. What about 18, 19, 20? Actually, this is over. So hash, this is our hash table. So in the hash table, so this is our hash table. Actually, at index 1, we are having one value, and at index 2, we are having two values, 2 and 42. Two key values are stored at this index 7. Can you view the slides? Is it okay? So at 1, we are having only one value. At 2, we are having two values, 2 and 42. That means it is a collision. We can store only one value at a particular index. So if we are having two values, means we are having a collision. This condition is known as collision. If we are storing two values at a particular index, then it is known as collision. Okay. Next, consider a hash table of size 2 whose indices are 0, 1, 2, etc. up to 9. Let the key values are 10. Okay, you write this one. Consider a hash table of size 10 whose indices. Actually, the problems in this module are very important, and you can do it. Very simple problems are. Okay, size is 10 and indices are ranging from 0 to 9. So let the set of key values are. Okay, you write it. I will read it. 10, 19, 35, 43, 62, 59, 31, 49, 77, 33. 10, 19, 35, 43, 62, 59, 31, 49, 77, 33. Okay, hash function is add two digits in the key. So we are having values, key values with the two digits. So our hash function is given hash function as add two digits in the key. So we have to add the digits in the key. Take the digit at unit place of the index result as index. First we have to add the digits, then we have to take the unit place and ignore the digit at the decimal place. So we index is the sum of two digits in the key and take their unit place. So our key values are like this. 10, 19, 35, 43, 62, 59. So first of all, you have to draw a table like this with three columns, key, hash, index. Okay, draw it and write fill the key values. You can write 10, 19, 35, 43, 62, 59, 31, 49, 77, and 33. Write the key values first. Hash column. So it is given that the hash function is sum of the digits. So what are the digits here? Key value. What are the digits? Tell me. First key is 1, 0. So what are the digits?
1 and 0.
Yes, 1 and 0. So take, so add it, 1 and 0. So after adding 1 plus 0, we will get 1. So we have to take the unit place. So what is the unit place? Unit place is 1. So index is 1. Did you got it? Similarly, you have to repeat it for the other numbers. Next number is 19. So hash is digits are 1 and 9. So hash is 1 plus 9. 1 plus 9 means you will get, what is 1 plus 9? 1 plus 9 means you will get 10. Take the unit place. Unit place means you will get index as 0. Okay, I think you got the step. Complete the steps up to 33. Okay, then tell me. Next, we have to construct a hash table from these indices. So these indices means these values. These indices means it is ranging from minimum value 0. What is the maximum value? Maximum value is 8. Actually, it is given that the size of the hash table is 10. It is given that consider a hash table of size 10. That means size of hash table is 10. So indices are ranging from 0 to 9. Size is given that it is 10. So it is ranging from 0 to 9. So construct a hash table with columns 0 to 9. Actually, no need of these colors. You can just write it. You have to put the columns and rows also. Then take the first key, 10. What is the index of that one? 1. So you can put 10 at index 1. Like that, complete the hash table. Then take the next number, 19. 19 is at index 0. So you can store 19 at 0th index. Then take the next number, 35. Index is 8. So at 8th index, we can store 35. Like that, you can store all the numbers. Kailas?
19.
19. Then any other numbers at index 0?
Yeah.
Then what about 1?
10.
10. What about 2?
2 ഇല്ല.
2 ഇല്ല. Okay, correct. 9. 3.
49.
49. 4.
59.
59.
31.
31.
31.
31.
77.
77. Yes,
77.
correct. Yes, correct. What about 5?
5 ഇല്ല.
No numbers at 5. Yes, 6.
6 ഇല്ല.
Yes, 6. There is one number 33. Last number. Did you miss it? Last there was 133. 33 means hash.
മിസ്സാൻ നമ്പർ കണ്ടില്ല. നമ്പർ
Yes,
എഴുതിയിട്ടില്ല.
yes, yes, yes. 33 means 3 plus 3. That means index is 6.
6.
So at 6 we will store 33. Then 7,
43.
8,
62.
62,
ലാസ്റ്റ് ഏതെങ്കിലും നമ്പർ ഉണ്ടായിരുന്നു? അതിൽ മിസ്സാൻ
35.
എഴുതിയിട്ടില്ല.
35 is also there. 35. 3 plus 5, 8.
35.
So you will get a hash table like this. So in the right hand side, the hash table is, this is our hash table. So look at location 4. At location 4, we are having 3 numbers, 59, 31, 77. That means it is a collision. Also at location 8, we are having 2 numbers, 35 and 62. That is also a collision. So we have to avoid collision. Then only the hash function will become a perfect function. So another example, let h of k equal to k modulo 15. Then if k equal to, keys are actually 25, 129, 35, 2501, 47 and 36. So what is h of k? H of k means actually hash function is given that k modulo 50. K modulo 15 means the first key is 35, 25. 25 modulo 15. What is the reminder? Tell me. 25 modulo 15. What is the value?
10.
10. So h of k is 10. So take the next number, 129. We are taking this number 129. So 129 means k is 129 modulo 15. K modulo 15. 129 modulo 15. So what is the value? 129 divided by 15. And take the remainder. Tell me. 9. So we will get 9. Next is 35. 35 divided by 15. Answer is, remainder is 5. Then 2501 divided by 15. And take the remainder. Answer is 11. 47 modulus 15. That is, answer is 4. Sorry, 2. Then 36 modulus 15. Answer is 6. So now we have h of k is this one. These are the h of k values. 10, 9, 5, 11, 2, 6 are the h of k values. So we have to store these keys in the array in a straightforward manner. That is, this 47 is stored at index 0, index 2. So these are the indices 0, 1, 2, 3, 4, 5, 6 up to 14. Because the maximum value here is 11. So we can choose some 14 is the maximum size of the hash table. So this 47 is stored at index 2. Then 35 is stored at index 5. Then 36 is stored as index 6. Like that, we can store all the values. Okay, did you got it? Actually, this 47 means 47 2. So 47 2 is this 47 is stored at location 2. So it is stored at location 2. So thus delete and find can be done in order of 1 and also insert. So deletion, find and insert can be done in order of 1. So what happens when you try to insert a key 65? 65 means what is the key value? H of k value. How will you get h of k?
65 modulo 15.
Yes, 65 modulo 50. 65 modulo 15 means what is the value? 65 modulo 15. 65 divided by 15.
5.
Yes, it is 5. 65 modulo 15 means it is 5. So we will already there is one element at the 5th index. 35 is at 5th index. So again, if we are trying to insert the 65 at location 5, it results in a condition known as collision. So we cannot store more than one element at a single index. So hash collision, this is the definition. Suppose two keys k1 and k2 hashes such that h of k1 equal to h of k2. Here, two key hashes into the same value, into the same index, and are supposed to occupy same slot in the hash table. So this is not acceptable. So such a situation is known as hash collision. So some popular hash functions are division method, weight square method, folding method, and digit analysis method. So first one is division method. It is one of the fast hashing function. So this hashing function is very fast. So here we have to choose a number h larger than the number n of the keys in k or equal to the size of the hash table. So first our aim is to choose a number h. This h must be larger than the total number. This n means total number of the keys, or it is equal to the size of this h must be the size of the hash table. So it is usually a prime number or a number without small divisors. So actually this number, this h is a number. It is actually a prime number. This h is a prime number or a number without smallest divisor. What is prime number? What is the definition for a prime number? Tell me, what is the definition?
Divisor 1 number and then
Yes. Otherwise, so division method, the hash function is selected as k mod h, where this k is the key and h is the hash function. And in this case, index starts from 0. If index starts from 1, then h of k is selected as k mod h plus 1. Okay, one example. So in division method, we are having a formula h of k equal to k mod h. If the index starts from 0. If the index starts from 1, then we have to add plus 1 also. So one example. Here h equal to 31 and k equal to 78. So how will you calculate h of k? Suppose the index starts from 0. Index starts from 0 means the equation is k mod h. K mod, here k value is 78. 78 mod h. So 78 mod h means what is the value? Tell me.
16.
Yes, 16. So we will get 16. So we will get 16. If the index starts from 1 means we have to add this plus 1. So plus 16 plus 1, that is 17. Like that, we can calculate the indices value. So advantage of this method is it is very fast since it requires just one division operation. Disadvantage is we have to avoid certain values of h. And good choice of h is primes not too close to power of 2. So primes which are farther away from the power of 2 is the good choice. So one more example. Like the keys are 123, 945, 234 and table size is 11. So then how will you calculate the address? We already told that the hash function is calculated using k mod h, where h is the size of the hash table. Okay, first key is 123 and table size is 11. So how will you calculate the hash function? Tell me. Key is 123 and table size is 11. So how will you calculate the hash function?
123 mod 11.
Yes, 123 mod 11. So answer is 2. Then next key is 945 and table size is 11. So 945 divided by 11 and take the remainder. So answer is 10. The next key is 234. 234 divided by 11. Then take the remainder. So answer is 4. So hash address of these keys are actually these values is 2, 10, 4. We have to divide these keys by the table size, that is 11. 123 divided by 11, 2. 945 divided by 11, 10. 234 divided by, actually this is 234. We can change this as 235. 235 divided by 11, that is 4. So hash addresses are these indices, 2, 10, and 14. So collision can be minimized if table size is taken to be a prime number. So here table size is 11. That means we can reduce the collision. So table size must be a small prime number. So next method is mixed square method. This method is also very simple one. Actually, first of all, here k is squared. Then hash function is defined as h of k equal to x, where this x is obtained by deleting digits from both sides of k square. So I will explain it. So actually, these keys are like this. 3 keys are given: 3205, 7148, 2345. So these are the key values. First, it is written that this x, h of k equal to x, and x is obtained by deleting x of digits from both ends of k square. So we have to find k square. K is given. So from this k, we can find out the k square. So square of this 3205 will be this number. Square of 7148 will be this number. Square of 2345 will be 5499025. Then after taking the square, we have to delete digits from both sides. That means here we are deleting 3 digits, 105, and at the same time 025 are deleted. 025 and this 102 are deleted. From both sides, we are deleting numbers. 012 and 025 are deleted. And at the same time, from the second number, again 3 digits from the left and 3 digits from the right. Y10 is deleted, and at the same time 904 is also deleted. Here also we have to delete 3 numbers. 549 is deleted, and from the right hand side, actually these numbers are 1, 2, 3, 4, 5, 6, 7, 8. So this is a 8-digit number. This is also a 8-digit number, but this one is a 7-digit number. 1, 2, 3, 4, 5, 6, 7. So since it is a 7-digit number, we have to remove 2 digits from the right end. So the answer is 90. So after deleting the 3 digits from both sides, you will get 72, 93, and for this number, you will get 90. So we have to select 4th and 5th digit. So this is another example. Here we are using 3-digit addresses. 3-digit address means actually we can select any number. This is our key 1, 2, 3, 4. Square is this one. 2, 3, 4, 5. Square is 5499025. 3, 4, 5, 6. Square is this one. Okay, from this we can select h of k, hash function. So hash function is we can select second digit, third digit, and 4, 5, 6th digit. So second, third, sixth. Second, third, sixth. Here also second, third, sixth. Here also second. So here we are selecting some other digits. Like that we can select. So actually it is given that select 3 digits at even positions from the right. From the right we are selecting the even digits. So 0, 1, 2. So 9 is at the second location and 3 is at the next location. Like that we have to select the numbers. So it is from right. So this is from right. 119. Did you got it? Hello. We can stop it here. Actually, closed means the hash table is considered as circular. That means after last position we have to search the first position. Open hashing means it is like a linear array only. After last location we cannot search the first location. That's the difference between open hashing and closed hashing. Okay, next one is open hashing, or otherwise it is known as chaining. The closed hashing technique deals with arrays as hash table. The main difficulties of this method are very difficult to handle the situation of table overflow. In some cases, table overflow will occur. So it is very difficult to handle this condition. Also, the key values are intermixed. Thus, the majority of the key values are far away from their hash location, thus increasing the number of probe, which degrades the overall performance. Since the numbers are far, we have to increase the number of searching steps. So it will degrade the performance. To resolve these problems, open hashing or chaining method is used. Here, hash table consists of an array of pointers, and each pointer points a linked list. So advantages of this method include an overflow of situation never erases. So if you are using a linked list, then overflow situation never erases. So the hash table maintains list which can contain any number of key values. Then next one is collision resolution can be achieved quickly. Also, insertion and deletion is also faster. This method is suitable where number of key values varies drastically. So disadvantage of chaining is extra storage required for field values. This is an example. So hash function is key mode 7. So this is our initial table. Key mode 7 means 7 is the size of the hash table. So 0 to 6. This is our initial hash table. Keys are 50. 50 mode 7. What is the value? 50 mode 7. Value 1. So at first location we are storing 50. Then 70, 700, 700, 700 mode 7. Answer
0.
0. So we will store 700 at 0th location. 76. 76 mode 7.
6.
6. So sorry. 76 mode 7. So we will store at 6th location. Then comes 85. 85 mode 7. 85 mode 7. Answer
1.
1. So already 50 is stored at first location. So we can use a linked list like this. So 85 is stored at first location. So we are using a linked list to storing 85. Then next number is 92. 92 mode 7.
1.
1. So again there is a collision occurs. So again we are adding another chain. So this is a linked list. So we add 92 like this. 73. 73 mode 7.
3.
3. Again one collision occurs at third location. So we will add a sorry, actually there is no collision after inserting 101 only 101 mode 7. We can add 73 directly. 10 mode 7 answer is 3. So we are having a collision. So we are using a linked list like this. Okay. Any doubt? So this one is an example for a collision resolution technique. So here another example is given 25, 42, 96, 101, 102, 162 and 197. Again the actually the table size is 7 only. 7 numbers are there. So we can use a hash table of size 7. So numbers are 25, 42 like this. These are the numbers. These are the numbers. So hash function is 25 mode 7. 25 mode 7 means you got 4. 4 means you can store 25 here. So this is how we are in the previous case at this location 1 we are having 2 numbers. So instead of storing like this, we are storing the index value here. Here we are storing the index value, and from the index value we are using a linked list to store all the key values. If there is no number, we can use a null value like this. The next important factor is load factor. Load factor alpha equal to number of elements present in the hash table divided by total size of the hash table. So load factor represents the average number of elements at each table entry. For open hashing, load factor is always between 0 and 1. For chaining, load factor can be greater than 1. So these are some comparison. Separate chaining and open addressing. Separate chaining is simpler to implement. Open chain addressing requires more computation. Separate chaining hash table never fills up. We can add more elements to chain. Open addressing table may be full. Separate chaining less sensitive to the hash function or load factor. Open addressing requires extra care to avoid clustering and load factor. Fourth point, separate clustering is used widely when it is unknown how many and how frequently keys may be inserted or deleted. Open addressing means it is used when the frequency and the number of keys is known. Separate chaining means wastage of space. That means parts of hash table in chaining are never used. In open addressing, slots can be used. Separate chaining uses extra space for links. In open addressing, no links are used. So application of hashing. Compilers use hash table. You will study compiler in the next semester. Actually, there you are using hash table to keep track of declared variables. A hash table can be used on online spelling checkers. If there is any misspelling, it will detect. Then it is used in game playing programs. Then it is used for quickly check for inequality. That means if 2 elements has 2 different values, they must be different. So these are the application of hashing.